Good morning, everybody. Welcome to a new try and a new unit. We are going to start today talking about solving equations. And this is pretty important because this is what algebra is all about. So we're going to kind of learn the ideas that algebra is based on. And to do it, we're going to need to think logically. So everybody put on your logic hats and see if you can follow me. So we'll start out with an example of the kind of thinking that we need to have. Let's say you have 15 apples and your friend had some oranges. In total, you and your friend have 57 pieces of fruit. How many oranges does your friend have? So take a minute, think about that, and then resume the video and see what you got. Okay, hopefully you came up with the number 42. Okay, 42 oranges would be the number of oranges that your friend had. Now, how do we get that? So what you might have done is you might have thought about, well, what number would I have to add 15 to in order to get up to 57? Well, 15 plus 42 does add up to 57. Okay, another thing you might have done is to figure out what number you'd have to add to this to get to this. You might have taken 57 and subtracted the 15 apples. If you subtract the 15 apples, what's left over is the oranges. And that could have gotten you either way. Okay, so 15 plus something equals 57, might have been your approach, or 57 minus 15 equals 42. Okay, the answer is the same in both cases. Okay, so this illustrates the kind of thinking we're going to be doing, and this second approach specifically says a little bit about the method that we're going to use. Okay, and what I would like you to notice here is the number of apples I have and the number of oranges I have. Those would be added together to get you the total number of oranges. So as we're talking about like recognizing key words, you might see total. You would have to add these two together. But with one of these things being unknown, we figured out what that number is, not by adding, but by subtracting. Okay, subtraction is what's called the inverse operation of addition. And we're going to look a little bit more into that here. So, the question we're trying to answer is how do we solve one-step equations? Specifically, we're going to look at addition and subtraction equations today. We're going to look at multiplication and division once tomorrow, but we're going to start just with addition and subtraction today. So, for this first example, here's how you would see something written down. And this is the same kind of thing that we saw in the last example. But instead of a word problem, this is just saying x plus 3 equals 12. That means some number x. This variable stands for some number. I just don't know what it is yet. So there is some number, I'm just going to call it x because I don't know what the number is, that if you add 3 to it, you get 12. Okay? So it's the same as just like a blank box that contains some number that we don't know yet, some mystery number, that when you add 3, you get 12. Okay? Now some of you might see what number that's going to be. Maybe you can't. It's fine. Here's how we're going to solve this algebraically. Okay, and you might notice I put it right here. Please write this down. Okay, this picture right here, you're going to hear me refer to as train tracks. And train tracks is the process that we're practicing here. This is the thing that we're going to need to understand how to use, because this process and this idea will work for every equation you ever encounter. Okay, this one you might just be able to tell what the number is going to be, so you might not think that you need this. But I guarantee you, no matter how complicated the equation gets, and a lot of them you're not going to be able to do in your head, this process is going to work no matter how complicated the numbers are. So this is what we're going to write down. This is what we're practicing, and this is what I need to see on your homework and tests. Okay. So we start with the equation. X plus 3 equals 12. To do our train tracks, what I do is I underline the problem. I like to draw a set of parallel lines here on either side of the equal sign. Okay, and what we're going to be doing is we're going to be balancing this equation. We're going to be maintaining the balance here. Now, what I mean by that is right now, this equation is in balance. The fact that we have an equal sign here, I'm saying whatever x plus 3 is, it's equal to 12. It has the same value as 12. Okay, these two things are equal to each other. You can think of like a set of scales like you may have seen in science, right? Where you have that's not a very good drawing, but I can get my idea. You have the same amount on this side as you do on this side. That kind of looks like a person without a head. Let's try that again. Okay, so you might see something like plate here, plate there. Okay, something like that. Again, it tips left and right as you put weight on it. Okay, so this is kind of what you want to think of. Right now, these two sides are equal to each other. Okay, and I want to keep it that way. In order to keep it equal, I have to, whatever I do to one side, I have to do to the other side. Okay, so if you think again about the scales, if you were to take 10 pounds and add it on just one side of the scales, well, this side would go down and this would go up, right? And it wouldn't be balanced anymore. If you put it just on this side, well, now this side is going to go down and that's going to go up. But if you took the same weight, if you took 10 pounds and put it on both sides, well, it's going to balance out and it's going to stay the same. Okay. It's the same thing for if you take away weight, right? If you take away a certain amount of weight, if you take away the same amount from both sides, it's still balanced, right? So we can add or subtract whatever we want as long as we do the exact same thing to both sides. That's the idea. And it's the same with the equation, right? So I can add or subtract anything I want to onto this equation as long as I do the same thing on both sides. So if I think about what I would want to add or subtract, well, right now I have x plus 3 equaling 12. Okay, so if I take a number, I add 3 to it, I get 12. Well, what I want to do, I don't want to know what 3 more than x is. I want to know what just x is. So what we're trying to do is we're trying to get this variable all by itself. Okay, we want this to be the only thing on its side of the equation. So whatever numbers are with it, here it's a 3, I'm going to want to get rid of that. And the way I get rid of that is by using this idea of an inverse operation, right? The inverse or the opposite of adding is subtracting. Okay, to illustrate that, think of a number, any number. Got it? All right, now take that number and add 10. Okay, now take your new number and subtract 10. I'm going to guess you ended up back with the same number you started with. Am I right? I hope so. Because adding 10 and subtracting 10, those are inverses of each other. Okay, they'll undo what you just did. Okay, so the way we solve these algebraically, and again, this is what algebra is all about. You see it right there in the word. So by doing the inverse operation to whatever's been done to the variable. So just like in the first slide, you might have figured out how many oranges there were by subtracting 15. Here we're going to get rid of the fact that 3 was added to x by subtracting 3. So we're going to do a minus 3 to cancel out this plus 3. Now, when we do a minus 3, don't forget this balance idea. Whatever we do to one side of the equation, we have to do to the other. So if I'm going to minus 3 here, I have to minus 3 here also. Okay, so what happens to this equation when I do that? Well, the plus 3 and the minus 3 cancel out, and they leave x all by itself, which is what we want. Okay, the equal sign is going to carry down because it's still equal. Do the same thing to both sides. On this side, 12 minus 3, I can do that. 12 minus 3 is 9. Okay, so when I subtract 3 from both sides, I get x equals 9. If this is true, then this is true because we kept everything balanced. And now here I have a statement that tells me what my variable equals. And that's what we're trying to do here. The whole point of algebra is to figure out what number the variable stands for. Okay, in this case, it's 9. Okay, now once we have an answer, we can check it. To check it, what I'm going to do is replace x with a number that I just figured out x is equal to. So I go back to my original equation, x plus 3 equals 12. I replace the x with a 9. So remember, this is saying that's the number that x equals, is 9. And I check it. 9 plus 3 equals 12. Is that true? Yes, it is. Okay. So that's the idea. Okay, we're going to do some subtraction equations as well. Okay, but here's a reminder. We want to make sure everything is kept equal and in balance. Okay, notice we got the equal sign in the middle. Let's do the double line. The left side must stay equal to the right, which means whatever we do to one side, we have to do to the other one. Okay, so looking at a subtraction example real quick. Here I have c minus 15 equals to 41. So I took some c, this stands for some number, I don't know what it is. I took some number, I can use any letter I want to stand for that number. I subtracted 15, and that left me with 41. So if I want to figure out what number I started with, I have to do the opposite of subtracting 15. Okay, the opposite of subtraction, the inverse operation, is adding. Okay, so when our equation has adding, we subtract. When it has subtracting, we add. We use the opposite thing to undo whatever's been done here. Okay. So to get rid of minus 15, I'm going to do plus 15. Remember to balance, I always have to do the same thing on both sides. Okay. All right, once I do that, the minus 15 and the plus 15 are going to cancel each other out. And now I'll be back to just whatever c is. Okay, it stays equal because I'm keeping it balanced. And then 41 plus 15 is 56. Okay, so c equals 56. To check this, I can come back to my original equation and replace c with that number, make sure it's right. 56 minus 15, if I subtract that, I do get 41. So that is correct. Okay. All right, let's try. I'll try one of these and have you try the other one. So let's start with this first one. 94 plus w equals 127. Now again, the thing I'm trying to do is I'm trying to get the variable by itself. So I see a w over here, see a letter. I want that by itself, which means I have to take this 94 and I need to get rid of it. Now, hopefully it won't throw you off that I have the w as the second number and you have the 94 as the first number. Okay, remember, order doesn't matter with addition. So 94 plus w is the same thing as w plus 94. Okay, so don't worry that it's coming second. All right, but 94 is being added to w. So to get rid of that, I have to subtract 94. Again, it's addition, I undo it with subtraction. But I always have to do it on both sides. Okay, so when I do that, adding 94 and subtracting 94 cancels out. And that means it's just w over here. On this side, I have 127 minus 94, which gives me 33. So w equals 33. Again, I can check by just replacing the w with the 33. 94 plus 33, if I add that together, should give me 127. And it does. So checked. Okay. All right. Why don't you pause the video here and see what would you do to both sides of the equation and what would you get for s? Okay, once you have an answer, go ahead and resume and we'll see if we got the same thing. Okay, so hopefully what you did to both sides is you subtracted 34, which is the inverse of adding 34. You should have gotten s equals 66. Okay, which if you replace in our original equation, you get a true statement. 66 plus 34 does equal 100. Okay. Now, the first few we did had fairly easy numbers there, or nice round numbers, but they're not always going to be, right? We can have fractions and decimals show up in these problems as well. Okay, and we've learned how to add, subtract, multiply, and divide all decimals and fractions. So if we know how to do that from earlier, shouldn't be a problem. But it makes the calculation just a little bit more work. Okay, so again, on this problem, y is what we're trying to get by itself. It's being added to this, so we're going to subtract that number to get rid of it. But I have to do it to both sides. Okay, so that gets me y equals. Remember, subtracting decimals, I need the decimal point lined up. 3 minus 3 is 0. 5 minus 2 is 3. Got to borrow here. 14 minus 8 is 6. So I get 63. The 0 would be after the decimal point. I don't need a point 0. And my answer is a whole number, 63. Okay. Let's look at some subtraction ones. So again, same idea. We're trying to keep everything balanced. We're undoing what's been done to the variable by using the inverse operation. Those are some kind of key terms you're going to hear a lot during these kinds of problems. So W is what I'm trying to solve for. I want to know what number W stands for. I'm going to undo subtracting 3 by adding 3. Okay, so that gives me W equals 13. If you check it, 13 minus 3 is 10. That is a true statement. Okay. All right, how about this one? Well, here, this time I have the x on the right side. Variable could be on either side. It doesn't matter. Okay, equal means equal. They're in balance. It doesn't matter which is on which side. Okay, but I want to get the x by itself. Okay, so I look at what is on the same side with that variable, and it's a minus 15. I want to get rid of that by adding 15. Okay, that cancels out, gets x by itself. And 27 plus 15 is 42. There's my answer there. Okay. So I got one with decimals here. Again, same idea. Don't let the decimals throw you. We know how to add and subtract those. Okay. So D is what I'm trying to solve for. We're subtracting 53.6. I'm going to undo that by adding 53.6. Okay. That cancels out. Gets D by itself. If I add those together, decimal points lined up. 8 plus 6 is 14. Carry the 1. 6 plus 3 plus 1 is 10. Decimal comes down. Carry the 1. 6. So I got 60.4. And there's my answer. If I plug that in, 60.4 minus 53.6 will in fact give me 6.8. Okay, so let me throw a little bit of a monkey wrench in the works here. These are the ones that can cause a little bit of trouble because of this. We didn't have to worry about these with addition because remember I said order doesn't matter with addition. Okay, a fancy way of saying that is addition is commutative. Okay, we studied that earlier in the year, the commutative property. Addition is commutative, which means you can switch the orders and it doesn't matter. Okay, 2 plus 3 is the same as 3 plus 2. Now with subtraction, that's not the case. If we change the order the numbers being subtracted, it makes a difference. So we have a slightly tougher problem here. Okay? You think 15 minus r, what a lot of people will do is they'll see, well, I'm trying to get r by itself, and there's subtraction here, so I want to add 15. Well, the problem with that is 15 is not the number being subtracted, right? R is what's being subtracted. It's being subtracted from 15. So adding 15 wouldn't help us here. It's not gonna cancel that out. Okay. So we got to take a little bit of a different approach here. I'm going to give you a minute to see if you can come up with a way to do this before we discuss it together. So pause the video here if you got time and think about how you can do this. Okay, once you got an idea, start up and we'll go through it together. Okay, welcome back. So there's a couple of different ways to handle this. Here's the one I'm going to suggest. Do you remember how I said we can add or subtract anything we want as long as we do it to both sides? Okay, as long as whatever I'm adding or subtracting is the same thing on both sides, I'm good. Okay, so if I look at this expression here, I said 15 is not the thing being subtracted. The thing being subtracted is r. So one thing I can do, this might seem a little weird, but I can undo minus r by adding r. May not seem like that's going to help, but let's see what happens. So if I add r to both sides, I don't know what r is, but r is going to be the same thing on this side as it is on this side. So even though I don't know what it is, I know I'm still balanced because I'm adding the same thing. Okay, so minus r and plus r are going to cancel out, leaving just the 15 over here. On this side, we have 6 plus r. I can't add those together because I don't know what r is. So I just got to write it just like that, 6 plus r. Well, we still have an equation. It's not solved yet, but how is this better than this? Well, this is better than this because now it's not a subtraction problem, it's an addition problem. And order doesn't matter with addition. Right, so 6 plus r is the same as r plus 6. So now I can get r by itself by subtracting away that 6. Again, now it's adding. I undo that with subtracting. Okay, when I do that, I get r equals 15 minus 6, which is 9. Okay, now that was a little more complicated. Just want to make sure I check that. If I replace the r with a 9, I get 15 minus 9 equals 6. And you can check, and that is true. Okay, let's try another one of those. 36 minus g equals 8. Okay, so again, g is the thing being subtracted. So what I want to do first here is I want to add g to both sides. Minus g and plus g are going to cancel out. Okay, then I get 36 on this side. On this side, I got 8 plus g, which I'm going to write. G plus 8. Again, order does not matter when we're adding. Okay, so g plus 8, I want it to be just g. So I subtract the 8 to get rid of it. I get g all by itself here. And here I get 36 minus 8 is 28. Okay. All right. So this last example, just make sure we can do this with decimals. Make sure those don't throw us off. The idea is very much the same. So some more room. All right. So we got minus r. We're going to add r. And that gives me 45 plus 8 on this side. 45.8, sorry. Equals r plus 32.1. Okay, just those two added together. Now I get rid of the 32.1 by subtracting it. Then I line up my decimal points. I get r by itself on this side. Over here, 8 minus 1 is 7. Decimal comes down. 5 minus 2 is 3. 4 minus 3 is 1. We get 13.7 for r. If you plugged that into a calculator, you would get this. All right, that's all I got for you today. Good luck.